Hey, 8th grade, this is lesson 3-2, just a little thing about solving and then graphing. So we're going to run through a couple of quick examples here just to give you some ideas on what you can do, what you can't do. Just remember on some of these, if you get something like 6 equals 12, that means no solution if that's what you end up with. And we're using purple today because of the Vikings being undefeated. There you go. So I'm just going to do, I'm trying to find one that in this beginning part actually has a solution. And I would say, nope. No. So here's number 15. 15 looks like this. And as soon as I see this 0 over here, I know that I could write it like this. Now at this point, if I'm making my little graph, I know that right here is that y-intercept at 10, so I can do 10 right here. And now if I really want to, I can figure out what the x-intercept is by putting 0 in for y, which is what they did back at the start. So I could just solve it now and put negative 10 over here equals 7x. Looks like negative 10 divided by 7 equals x. It looks like 1 3/7, actually, negative 1 3/7. That's what x is, negative 1 3/7. Let's say it's about there. My graph looks like that. So the book is expecting us to graph and then solve, and the way we've actually gone about it, we are graphing, or we're solving and then graphing. So that was 15, and the thing I didn't do is I didn't make it into standard form, which I could do 7x minus y equals negative 10. Now, if I cover up, whoa, that's not what I wanted to happen. If I cover up that, I get negative y equals negative 10. That means the y-intercept is 10, which is what we see right over here. If I cover up the y, I get 7x equals negative 10. And then if I divide each side by 7, I get the same thing, that x is negative 10 over 7. Works the same way. Standard form works great, slope-intercept form works great, and even this beginning part works great for everything. So there's the first example. Now, normally I would say get rid of everything on the bottom, but this time I'm not going to, because I'd really like to keep that 0 there. That's a nice way of finding out what an intercept is. So I'm going to leave it for this time. One thing I am going to do, though, I'm going to rewrite it with negative 2/5 x plus 3/4. And right away I know that my y-intercept is 3/4. So if I say 1, 2, so 3/4 would be about right there. Yeah, that'll work for now. Now, what I could do to find the x-intercept, since I already have 0 in for y, because remember, you want to find x-intercept, put 0 in for y, which is what they did. So I could do the pen, subtract 3/4 from each side to get this. Now, I have a negative on both sides, which makes everything positive. Now, if I multiply each side times the reciprocal, 5/2, I should end up with 15 over 8 equals x, or 1 7/8. That seems to work very well. So if I do the same thing about 1, 2, 1 7/8 is going to put it about there. And when they're talking about solving by graphing, well, that just tells you what is your x-intercept. That's really what they're asking. So again, doing it that way works really well. We have the y-intercept there. We just solved it with the 0 right there to get 1 7/8. The other way to do it, come on, goodbye. There we go. The other way to do it is put it in standard form. So then you would have 2, if I move the negative 2/5 to the other side, 2/5 x plus y, because remember, I'm making, y and 0, that's what they're doing. They're making that the same, and 3/4. So again, now, if I go back to my good friend the square here, if I cover this up, I know that y is 3/4. It's that simple when you have that 0 and that 0 there for y. If I want to let's try my square again. Cover up that, you have the same equation we had before. 2/5 x equals 3/4. So I multiply times 5/2 times 5/2. Everything here cancels. X equals, again, 15/8. That's your x-intercept. That is your answer. So this is number 39, which is different because you don't have a 0 on one side. So you need to get a 0 on one side to do what we're doing. Yes, you could just solve this for x and find out, but let's move everything to one side. I'm going to move everything this way. Just because the x on this side is smaller. So that's minus x, and I'm going to do minus 13 at the same time. Minus x, minus 13. So you get 6 plus 2x equals 0. And if I flip that around, I get 0 equals 2x plus 6. So now I know y-intercept is 6. Let's pretend that that's about right there. Then, if I solve this for x, then I'll get the x-intercept, because I have 0 in for y. So minus 6, I'm going to get negative 6 equals 2x. That should tell me, if I divide each side by 2, x is negative 3. Now let's pretend that's about there. Whoosh, just like that. So there you go, get everything to 0. You could also do this in standard form, except you'd have to put in y. So you'd end up with, if I go to this, the 6 plus 2x equals y. Then if I want to get y on the same side, 2x minus y equals negative 6. So I just flip the y and the 6. Go back to my wonderful shapes here. And now if I cover up, nope, let's try it again. If I cover up that, so negative y is negative 6, that means y is 6. And if I cover up this, I should get that thing that we had before, 2x equals negative 6, x equals negative 3. So all works the same. And then finally here's number 44, which gives you this equation. T is time, and P is the percent of the process left to complete. So that should make sense then, that if this is the y-intercept, that means when you start, you have 100% of the process to complete. So that should be, as we know, the y-intercept at 100. And that should make sense, because if you think about it, if you put 0 in for t, 0 in here, that's like putting 0 in for x. That tells you the y-intercept. So if there's 0 time being done, or having been done, then you have 100% left. And then every minute, it looks like every minute you're getting rid of 12.5% of the process. So you could right now go down 12.5 over 1. You could go down 12.5 over 1, and you could graph it like that until you get to 0. You zero out your y. That should tell you how much time it takes for the process to be done. That would be a 0 here. So if I go back to this, 0 equals 12.5t plus 100. There you go. You have 0 in for y, or for p. So now I should have negative 100 equals negative 12.5 t. And divide each side by negative 12.5 if you want to do it that way. I don't know what that is even. So you're going to get this nice number. This will be positive, positive, and you're going to get some number. Tells you how much time it is. And since we've zeroed out y, anytime you put 0 in for y, that tells you the x-intercept. So you're going to get an x-intercept here, and what that should tell you is after x number of minutes, your process is done. There you go. Hope that helps. Smiley face, and go Vikings. Boo Packers.